Big Ben and Antonio Brown and all the weapons over there. So he attended Cal U. He's got 2 bachelor's degrees there, one in chemistry and geology. He's got a law degree from Duquesne. So Tom's going to be talking about the Kemper plant because DOE invested 5% early on in that plant, and he works for the fossil lab, the NETL lab, and of course we're very proud to have the Savannah River site just across from our plant Vogel, and these labs, I really like the attitude of these labs. I was at NREL in Colorado not too long ago. It's just an open for business attitude, you know, and I really hope that we'll continue to take advantage of these national labs and the resources that they bring. So we're going to hear a little more about Kemper. Let me just say, you know, I regulate Georgia Power. Of course, they're in that Southern Company family. I mean, we're cheering for Mississippi. We want them to be successful, you know, with this technology, and you know, as you know, of course, the plant's I guess burning gas right now, right? So hopefully we can get this technology rolling, and it's just whenever you're doing first of a kind projects, you know, and Southern's got these 2 going on now with you know, with Vogel and with Kemper. It's just a risky thing, and I'm anxious for us to get both of these plants up and running, and I think there'll be others who follow. So kudos to Southern for their risk-taking posture. So Tom, fill us in on the Kemper technology, and hopefully you're as hopeful as I am about this. Thank you.
Yes, you have to be an optimist in this business, that's for sure. This morning, when Tim was going over things with me, he looked at me and he said, "You're talking about Kemper? There must be 20 people in the audience from Southern Company. Why are you talking about Kemper?" I guess I'm something of a risk taker in a very risk-averse organization, and I routinely get into trouble, and I suppose my remarks this morning will do no less. As the Commissioner mentioned, I work at the U.S. Department of Energy's Implementation Lab for Fossil Energy Technologies. There are 17 DOE labs. 3 of them deal with commercial energy. NREL, as you know, is the National Renewable Energy Laboratory. The Idaho National Laboratory concentrates on commercial nuclear power, and fossil energy, coal, oil, and gas technologies are mainly done at NETL. The Department of Energy is contributing, is this the?
That's the
clicker?
Where is our, yeah, this is the clicker, the green one.
Good, sorry for the interruption. We're contributing $270 million toward the demonstration of the Transport Integrated Gasifier, which we call TRIGT at Kemper. That's actually a little less than 5% of the total plant cost, including the coal mine and the CO2 capture equipment. However, DOE's and NETL's support of TRIGT, or Transport Integrated Gasification, stretches back many years, something like 15 years or more, to the pilot-scale Power Systems Development Facility at Wilsonville, Alabama. I think Southern Company had a staff of about 60 people there that worked on the pilot plant, and you know, that's one good way for a power company to break into this chemical-like gasification arena. There are other ways. A few years ago when AEP wanted to get a gasification off the ground, but they never really did, they hired a group of 5 people from a chemical company. So there are different ways to do it, but Southern has developed over many years a great core of expertise at Wilsonville. And the original facility at Wilsonville was called the PSDF, Power Systems Development Facility, mainly for gasification research, and in recent years they've added the National Carbon Capture Center at the PSDF, which you heard about yesterday in Jared's presentation. So not only are we contributing a little bit of funding to Kemper, but we have in our DOE fossil energy R&D programs have invested heavily in adapting KBR's fluid cracker technology, which is what this is. It's used in oil refineries in a different application. And the Southern Company has adapted this to gasification for electric power generation. Now, TRIGT can be designed for either air-blown or oxygen-blown gasification. And, you know, the gasification technologies are all different. I mean, some of them work better with bituminous coals. That's not to say they can't use low-rank coals, but they function better with bituminous. And this particular technology functions better with the low-rank coals. And the lower rank, the better. In the case of Kemper, they're using Mississippi Lignite, which is a very low-quality fuel. Probably wouldn't, you know, most people would probably pass on using it. The Kemper IGCC plant is located in Kemper County in east central Mississippi near the town of Meridian. The plant is sized at 524 megawatts on syngas and 582 megawatts with supplemental induct firing of natural gas. It will utilize what I call a 2x2x1 configuration. That is 2 air-blown TRIG gasifiers, and they are air-blown. I had somebody a couple weeks ago arguing with me, telling me that they were oxygen-blown. No, at Kemper they are air-blown. 2 Siemens SGT6 5000F combustion turbines, and 1 Toshiba steam turbine, 2x2x1. The plant will capture over 65% of its CO2, which will be sold into enhanced oil recovery applications. Also important to the project economics, the plant will utilize Mississippi Lignite from a new surface mine adjacent to the power plant. I only know of one other lignite mine in Mississippi. The inset map at the lower left shows the locations of various lignite deposits along the Gulf Coast. Now, as you've probably heard, if you've heard about the project, this is a rather massive project. It's the largest project that NETL or DOE's Office of Fossil Energy has been involved with in anybody's memory, and it's the largest by far, by multiples. It involves 70 miles of transmission lines, 60 miles of CO2 pipeline to connect to the main CO2 pipelines, and I mentioned the lignite mine, 31,000 acres. Here's a block flow diagram. As you know, an IGCC plant couples gasification with combined cycle power generation. There are, I don't know, 300 or 400 coal gasification plants around the world. If they don't make electricity, they're not IGCC. They're just a regular gasification plant. When the 2 Kemper trains start up next year, they'll become the 11th and 12th IGCC units in the world that were designed to operate on coal. The others, just for memory, and I guess the list is growing, are Boegenum in the Netherlands, which started up in 1994, Wabash River, Tampa Polk Unit 1, Portillano in Spain, Vršova in the Czech Republic, Nikoso in Japan, GreenGen at Tianjin, China, and the 2 units at Edwardsport, Indiana. One time, one of our directors about 10 years ago came and asked me, Tom, when is gasification IGCC going to reach the point when industry can do it on their own without any form of government assistance? And, you know, that's an it's an imponderable question. And I said, well, you know, I think the world for IGCC will look different when we have 20 of them. Well, Boegenum started up 20 years ago, so we have 10 unit trains, 10 unit trains in 20 years. Hopefully the next 10 will go a little bit quicker. But they are impressive facilities and they're complex. It's hard for me to go in and explain to people what I do at NETL. Yesterday's chair, Roby Lewis, mentioned TRLs, Technology Readiness Levels, and his program works with Technology Readiness Levels 1 through 4, the very nascent, more basic research. And then our R&D programs for gasification, turbines, fuel cells, and so on, they take the technologies from TRLs 4 to 6. I work in the major demonstrations program, and what that means is that I work with technologies, TRLs, and Kempers. An example of this, all the technologies being demonstrated are at TRL 7, or possibly 8 or 9, and we couple them together and we do a lot of technology integration. Importantly, of all the IGCC plants that I just rattled off, Kemper will be the very first IGCC plant anywhere to shift the syngas to high hydrogen syngas and capture 65% of its CO2. It will use water gas shift and select sol technology, and here's a schematic of the CO2 capture scheme. Construction is nearing completion. Various subsystems are in different stages of shakedown and startup, and operations crews are in training. The combined cycle has been placed in service on natural gas in August. The Lignite mine is operational. I mean, you wanted the mine to be operating and be ready before the power plant is, and it's basically awaiting startup of the IGCC plant. Now I'm going to run through some photos and hopefully make up a little bit of time. Here's a photograph of the control room, and walk through history. This is what the site looked like in 2010. Here it is that was June of 2010, and here it is a little over a year later, and it's starting to resemble the building of the pyramids. Here you see the result mostly of civil work, but if you look closely, you'll see the steam turbine pedestal sticking up to the left of center. Another 1 year later, you can see 2 Hercigs in their stacks on the left, and the gasification structure at center right. And by the fall of 2013, you can see much of the supporting infrastructure, such as the gas cleaning systems and the cooling towers. The construction workforce peaked at more than 6,000 people in late 2013 and early 2014. When I visited the plant last, this past July, there were 4,100 people on site. Needless to say, this project has been an economic boon to East Central Mississippi and the adjoining areas of West Central Alabama. Here's an aerial overview of the plant showing some of the major features, such as the Lignite storage dome on the right. The new Liberty mine is at the top, just past the treated effluent reservoir. We have the major subsystems circled in yellow and identified in yellow type. Here's a closer view of the combined cycle. Some shots of the Lignite conveyors in the storage dome. At left, inside the storage dome, looking up, at upper right, an aerial view of the Lignite conveyors in the dome. And at lower left, a more artistic shot of the storage dome. I can tell a funny story. It's, you know, there are like 1,200 people at NETL, and it's hard for me to explain exactly where I fit and what I do. So I was at one of the conference rooms at DOE headquarters several years ago, and people were saying, well, who are you, what do you do? And I looked on the wall of the conference room, and there were photographs of the Tampa and Wabash IGCC plants, which I helped to fund. And I pointed to those pictures, and one of my colleagues from headquarters said, yeah, Tom helped with those 2 projects there. And automatically, I mean, I could say it in words and nobody knows what I do, but when you point to plants like that and like this one, then something clicks and it's like, oh, okay, we get it now, we understand. And that's all because we had a very famous artistic shot of Tampa. And somebody actually showed it yesterday. And Tampa started up in 1996. So we're still using that photo 18 years later, and I like to get some artistic shots of Kemper that we can start using to show the new generation of IGCC plants. And this one at lower right may be one of those photos. Here are some photos from the gasification area. You know, we talk about a technology supplier. Is it General Electric or B&W or Foster Wheeler or Alstom or MHI, Hitachi? And there are hundreds of suppliers that feed into each of these plants. By the same token, when we talk about the gasifier or the gasifier structure, there are many, many parts. I attended a presentation several months ago, at which somebody from Duke said that Edwardsport has 700,000 linear feet of pipe. Well, Kemper has over 1 million linear feet of pipe. These are not for the faint of heart. Here's some photos from the gas cleanup and byproducts area. And this is the Liberty Mine. You know, purposely not talking about costs because I think it's something of a red herring. We need an infrastructure. We saw yesterday that our plants are like 44 years old on average. In 20 years, it's going to be untenable. And with CCS looming on the horizon, I don't see any way around it. We're going to have to invest hundreds of billions of dollars. And the alternative is to sort of go down the path that Paul Chodak mentioned yesterday, like Germany and some of the European countries. And if we want to go down that path, then it's going to cost trillions of dollars, not hundreds of billions of dollars. And there are economists who will back those guesstimates up. And so when we look at cost, you know, Kemper is expensive, but when was the last time you analyzed the cost for a power plant and you included the cost of a 31,000 acre coal mine in it? We're doing things for the first time, and that necessarily means a high degree of conservatism. When you look at a reactor and you say, well, we can design this and we think it'll function in a maximum range of 50 psi to 100 psi, what are you going to design it at? 100 psi. If it runs well, we may be able to back off for the next one and learn from that. At Wabash River, we did design studies and came up with over 200 potential improvements that could be made on a second plant. So there are learning curves and learning by doing exercises that will be done, and you know, you have to saddle up. These things are going to cost what they're going to cost. And frankly, I understand that until we get this running sometime next year, late 2015, early 2016, a lot of people aren't going to have much to say about it or to talk about short of, you know, what's it cost. But hopefully I've shared some photos with you today and a little bit of technology background to appreciate and understand this in a little bit more detailed context. With that, here's my contact info. I'm on LinkedIn. You can reach me there. I'll be around at least through lunch today, and that wraps up my tour of Kemper.
Okay, we got a few minutes for questions. So, wow, this is an exciting plant. Thank you for being involved with bringing this new technology to our country. And it sounds like that we've had, you know, the technology has been around. We just haven't really needed to use it. Now we're having to go there because of our regulations and whatnot. So, questions for Tom? Get our microphone ready. Certainly, you have a question about the state-of-the-art coal plant. Yes, and if I could have Kathleen make her way up to the table. Yes, ma'am.
Kristen Jenkins, CH Tom Hill. I was wondering about wastewater and how it's treated and whether it's discharged.
It is I had it on one of my slides here, and I don't know in great detail about the specifics of it, but we have, it is a zero liquid discharge plant, and I think there is some water coming from the city of Meridian, so some of the water is definitely being treated, but I'd have to defer to my colleagues from Southern Company on the specifics for you.
Does anybody from Southern know that can answer that question for us here? No? Okay. Other questions? Yes, sir.
Tom, how have you been first? I haven't seen you in 15 years, but
Yes, it's
good
been
to
a while.
see you again. What's the efficiency of the plant, Tom, with and without the CCS operating?
Don't know those off the top of my head. I'm guessing they're in the 30s, you know, the mid to high 30s without, and the probably low 30s, around 30 without. But I can dig those up and get them back to you. You know, CCS, you take a hit. And one of the things that was in Jared's presentation yesterday, you know, before we did any of this, before AEP tried Mountaineer, before Southern Company tried Plant Berry, people were throwing around these scary numbers like 40%. Well, I think at Plant Berry, they've shown that if you have a motivated, well-motivated team, you can make that 20%. So, you know, 40% is kind of going by the wayside. You dig up some old papers, sure, you're going to find 40%. But that was a huge milestone that's come from a 25 megawatt pilot plant. And what we see with a lot of these technologies is, sure, it's fun for me to come and talk about a 500, 600 megawatt state-of-the-art plant, but to get some of these technologies up to TRL7, we're going to need more, we may need more pilot plants like the one at Plant Berry. You know, the 25 megawatt stepping stone that you can use to go to 100 or 200 megawatts or larger.
Any other questions for Tom? All right, great, sir. Thank you very much.